goals were pretty simple. Our goals were basically just all the requirements of the project. We had to design the robot with appropriate sensor placement. We had to be able to follow the line. We had to be able to code for the arch and brick. And that's mostly it. Our imagination process was our shortest process. We already knew the design we wanted. We knew the sensors needed to be close to the ground and on each side of the black line. We also knew that the touch sensor needed to be in front to hit the brick. Also, the ultrasonic sensor had to be high enough up to detect the arch when our robot was going under the arch. And as you can see, we had the light sensors really close to the ground and the ultrasonic sensor really high up so it could detect the arch. Although we did have an issue at the beginning because at first we didn't realize the light sensors had to be on the front, so we were running into a lot of problems. And that's when we made the change.
To accomplish the project, we split up into coding and building teams. One group consisted of Alex and Andres, while another consisted of Omar and Sean. Omar was the main coder, while Sean worked on another computer trying to make his own code. Sean also recorded test runs and took pictures as we went along. This allowed us to evaluate problems we had in the main code and look at Sean's for advice. Building the robot was a bit tricky because we had to make room for all the sensors. Alex and I struggled a bit, figuring out where all the components would fit best and be able to record information. Our high priority tasks were creating the code specifically for line following. This was the most essential part of the project and took us the longest time. Also, making sure that the sensors would pick up information accurately was at the top of our list. There were no low priority tasks because they were all essential to finishing the project. We spent the least amount of time, however, on design because the coding portion was so strenuous. The arch and brick were not as time consuming, but again, were essential to finishing the project. For the pseudocode, we sat down as a group and worked together. We knew we had 4 options for line following: white, white, black, black, and black, black, and that each option provided a separate action such as turn right or left. Our pseudocode wasn't the greatest because we didn't spend enough time working on it. We put most of our energy in trial and error test runs. In the end, we all came together and helped finish the project, giving advice on all parts, coding and design, to make sure the project would run smoothly.
The process we used to complete this challenge was trial and error, and here is just one of our classic examples of a trial and error session.
He's put the code in the robot. He unplugged the cord. He sets it.
What is this,
Oh, perfect.
More time.
Like most groups, we had a lot of bumps. One of our biggest bumps was just agreeing with each other on various things. Another bump was figuring out where we should put our light sensors. We spent so many days working on that in the beginning, we were running low on time at that end. Also, another bump was determining the threshold value, because originally we didn't even use a threshold value. We were just using 35, and that just wasn't consistent and that just could never work. And finally, to go along with the threshold, we didn't even have a calibration code in our robot C, and we sort of just winged it on the day of the test, which was not what we should have done. While figuring out where to place the light sensors, it gave us a lot of inconsistency, as you can see. Sometimes we get it, and just sometimes we wouldn't. This inconsistency was occurring because of the placement of our light sensors and because of using a solid number 35. We should have used an actual threshold. Our main breakthrough was establishing a threshold value. Using the number 35 was just inconsistent and could vary based on the lighting of the room or other obstacles. Another breakthrough was finding a right place for the touch sensor, because we had a slot for the touch sensor, but we couldn't figure out a way to make it big enough for the touch sensor to actually fit. So through a lot of test and error with designing, we finally figured out the correct placement for the touch sensor.
While we were satisfied with our robot's performance for the most part, there were 2 areas in which we could have improved upon regarding its performance and group work. The first takeaway is regarding the sequence in which the robot interacts with the arch. And the way we could have improved upon that is by resetting the integer that we had set up for that sequence. So we had it set up in a way in which the code would add 1 onto the integer as to prevent it from going on an infinite loop. But after that, we had forgotten to reset that integer, and we could have done that by having reset it once the touch sensor was pressed for the brick sequence. And by doing so, the robot would be able to interact with the arch a second time instead of ignoring it after the first. Our second takeaway is regarding group work, in which we could have improved communication, and by doing so, we might have been able to avoid having to print out the robot seed the day of the competition.
Overall, our group was pleased with our performance. All we missed was a few points, including doing a loop under the arch, doing a sound after the brick, and we had to pick up our robot once.
So Alex, what do you conclude about this project?
I conclude we had a lot of ups and downs, you know. We didn't get the arch the second time, we had to pick up the brick once. That was just really disappointing. I honestly thought we were going to do a little better than that, but I was really happy with my performance. We got a solid grade, had some nice group members. I had a very good time.
You recording?